Although gNMI only has 4 RPCs, the overall service structure is more hierarchical and more complex. Just like we did with the iOS XR specific gRPC services, let's review the gNMI.proto file first. This file is more than 450 lines long and is heavily commented, so I'll jump down to the interesting part. The gNMI service contains the 4 RPCs we discussed in the slides. As is true for all gRPC services, there are inputs and outputs, which are typically categorized respectively as args and replies, or requests and responses. Notice that the get and set RPCs take exactly one request and return exactly one response. We'll examine these objects soon, but you can contrast it with the subscribe RPC. Both the request and response are streams. We'll need to consider this when we write our code. Let's first examine the GET request message. Although gNMI has fewer RPCs than most vendor-specific gRPC APIs, the object structure is more complex. For that reason, I'll only discuss the fields that are relevant for our demonstration. The GET request contains a collection of path objects, which is indicated by the word repeated. This allows operators to query multiple paths at once. The type of request is identified by this enumeration, allowing you to differentiate between configuration, state, or operational data. We also need to specify the encoding. Here are the encoding options which are contained elsewhere in this file, and we'll be sure to translate this into a Python class to simplify our scripts. Let's examine the path message, which is the key part of the GET request. This contains a deprecated collection of strings called element, which was the traditional way of specifying paths. We'll ignore that as it isn't commonly used today. The newer mechanism is to use a list of path elements. Each path contains path elements, which are just components of the path. These path elements contain a name and a string-to-string mapping of key value pairs. We represent this map as a dictionary in Python. To give an example, this is what the path element would look like in pseudocode form. We'll see more of this structure as we write our code in future clips, so don't worry about memorizing it. Next, let's quickly review the compile.sh script. Just like in the previous module, I don't want to type out these commands, so we'll use this script to compile Python bindings for our gNMI RPCs and objects. Be sure to include the extensions file. This file is imported within the main gNMI.proto file we just reviewed, which means we need to include it. It contains some additional data types and other protocol extensions. Let's run the script and check the results. Now, we see 4 new PB2 files, 2 from each proto input. We'll import these modules into various Python scripts in the following clips.